In this video, we're going to find the real zeros using rational zeros theorem. First, we're going to find factors of p, and p for our case is constant 4, and factors are -1 times -4, +1 times +4, or -2 times -2, or +2 times +2. And for q, we have a leading coefficient of 1, and when we factor that out, we have -1 times -1, or +1 times +1. So using rational zeros theorem, we know that plus or minus p over q equals plus or minus 1, 2, 4 over 1. And we can put one of the factors over one of the factors from p over one of the factors of q, but here we have only 1 in the denominator. So when we list all possible rational zeros, we have -1, +1, -2, +2, and -4, +4. For b, it says find all the real zeros. We're going to use the remainder theorem. So when I use the values that we found from A and substitute those x values into p of x, and I get 0, then I know that that's a factor of p of x. So I'm going to check p of -1, which is -1 to the 4th minus 5, -1 squared plus 4 equals 0. So we know that that's a real number, real 0. And p of 1 equals 1 to the 4th minus 5, 1 squared plus 4 also equals 0. P of -2 equals -2 to the 4th minus 5, -2 to the square plus 4 equals 0. And p of 2 equals 2 to the 4th minus 5, 2 square plus 4 equals 0. However, p of -4 does not equal to 0, and p of +4 does not equal to 0. So we can say that real zeros are when x equals -1, 1, -2, and 2. That's for b. For c, using this information, we can say that factors of p of x are x plus 1 from x equal -1, and x minus 1 from x equal 1, and x plus 2 from x equals -2, and x minus 2 from x equals 2 from b. So these are the factors of p of x.